Hi students, the goal of this first lecture is just to kind of go over some intro stuff, what is geology, and what is the scientific method. So let's get into this. So right now we're going to get to know me a little bit. I know that you've introduced yourselves on the discussion posts and all of that good stuff and talk to each other a little bit, but I'm going to give you a little bit background information on me, and I am an open book, so if you have any questions, feel free to ask. We'll talk about what geology is and kind of debunk some of the misconceptions about science and geology in general. Then we're going to learn some key concepts about geology and then review the scientific method. Okay, so I'm your typical geology person who loves the outdoors, likes looking at rocks, of course, going to Yosemite, all of those good things. But I also love things that aren't necessarily typical geology stuff, like going to Disney. I play softball with my husband, and I coach my daughter's softball teams. And we are a little family unit of just the three of us. My husband is an engineer in Fresno, and my daughter is 8. She will be 9 in September, and she's going into the 3rd grade. Oh my goodness. So if you ever have any questions about me or what I like, let me know, or how I got to where I am. Like I said, I'm an open book, but I won't bore you too much with things about me. Okay, so geology is the study of the earth. So here we're looking at any physical thing or change, physical or chemical, on Earth that is happening. So are we seeing some chemistry below our surface that is creating magma, that is then creating magmatic eruptions, things like that? Coastal erosion, like you see in this little mini video here, are all part of what we study in geology. It's not just rocks. A lot of people think it's just rocks, but it's not. It's faults, earthquakes, volcanoes, tsunamis, all of that good stuff. So we will talk about a lot of different things throughout this course. Okay, so here's a little definition for you what the study of geology is. And like I said, it's not just about rocks. We will also study things like some of the paleontology, so looking at fossils, which is a little bit of biology. So if you'll notice throughout this course, we will go through all of the different sciences from a geologic perspective, from an earth perspective. So with chemistry, I mentioned, when we're looking at volcanoes, we need to understand the chemistry in the magma chambers. When we look at minerals, we need to understand chemistry and how elements combine to make these minerals. When we're looking at landslides, we want to look at things like force and gravity, which are all physics properties, right? And then when we're looking at paleontology, we're studying fossils, we're studying past life. Past life is all biological, right? So we take all of the sciences and we combine them into learning about Earth. All right, so let's get comfortable. I have a link listed underneath your presentation that will take you to a Padlet, and that Padlet, I want you to post assumptions that you've made about science or geology. You can also write down something you're curious about, and we'll start answering those throughout the week. And this is not something that's graded, but it's something to kind of get you maybe to feel a little bit more comfortable. I will tell you, one of the most common ones that I get are the fear of math. So I know that math can be very scary. Trust me, I failed calculus twice. So just because you fail a class doesn't mean you can't get to where I am without perseverance. So you can persevere through math even if you don't feel like you're that great at it. So, but in my class, I am here to teach you geology. So I want you to learn the geology first, and then if math is a subset to that, great. If not, take a math class. You will have to take a math class at some point, but I'm not here to have you run through huge calculations to try to get you to an end result to understand slip rate or fault motion or anything like that. So we will do a little bit of math, but it'll be mostly algebra, and a lot of it will be plug and chug. So I'll give you an equation. You'll just plug in the information and you'll understand the answer. And so those answers will tell us things like how fast a fault is moving. So if we calculate something and our fault seems to be moving at several feet a minute, calculated something wrong, right? So faults don't move that quickly. But if we calculate that it's a few centimeters a year, that's closer to an answer we're looking for. So we use the math, but it's not all about the math, okay? So don't be too scared. So if there's anything that you want to write down in this Padlet, go for it. I think it'd be really interesting to see some of the questions you guys might have or some assumptions you might have, and I will help try to debunk those for you. Okay, so what do we care about geology? Doesn't matter. It's just rocks. Well, it's not. So we do care about geology because it impacts everybody on Earth. Since it is the study of the Earth, it impacts everybody that lives here. So if you live on Earth, you are affected by geology. Okay, so there's volcanic eruptions, there's earthquakes, we have environmental issues, there's rock falls, landslides, all of that stuff impacts everybody on Earth. It impacts our bottom line. So if we have these natural disasters occur and we have to rebuild and spend a lot of money to rebuild these areas, if we can start with better infrastructure, the construction process to rebuild is not as costly. But as you can see in this image, these buildings are pretty torn up, and that happens due to poor infrastructure during an earthquake. Okay, so that's why it matters. And if you are that curious about it and would like to become a geologist, that would be the best thing on the planet. But there are lots of different things that you can do. So I used to work in an environmental perspective where I did air, soil, and water contamination and cleanup. So if, for say, a gas station had a leaking gas tank, we would look into the soil and see what the concentrations were and see if it made it to groundwater and do all of those investigations and then hopefully clean all of that up so that the gas is not sitting in our groundwater or in our soil. And the soil problem is not just that it can seep down into groundwater, but it can also come up into buildings and cause some indoor air issues. So you're inhaling some of that gas or diesel or whatever it is. Maybe it's from a dry cleaner. All of those things being inhaled over your workday is not good for your health. And so we were in charge of trying to mitigate that and clean that up after people were not taking care of their tanks and they weren't disposing of chemicals properly. And so that's just one thing that you can do. There's many other things. You can do petroleum geology and work for things like Chevron, looking for oil and gas. You can do some paleontology where you are basically like an Alan Grant, where you get to look at dinosaurs all day and uncover them. You can work in seismology where you study earthquakes and their effects on buildings and people. You can do volcanology. You can go to Hawaii and you can be a volcanologist on the Hawaiian volcanoes and study their chemistry. There's all kinds of things that you can do. And you can make quite a bit of money, just depending on what you're looking at. But the standard geologist makes $83,000 a year. Petroleum geologists make a lot more money because it's a very lucrative business. It's not great for the environment, but it's lucrative. And then, as you can see, physicians will make a lot of money, but how much time do they spend at the hospital or the office, right? They are very dedicated to their work. And obviously we need healthcare workers, but they don't have a very good work-life balance. I would say that even as a consulting geologist, I had a very good work-life balance. I didn't feel like I was chained to my desk all the time. And the competition is low. So if you look at graduates coming out of college, only 0.2% of them are getting earth science or physical science degrees. So that is a very good position to be in because there's lots of opportunities for jobs. And we have great jokes. So this will make more sense when we get to rocks, but gneiss and schist are a type of rock. Hopefully you understand the other one. What do you call an Irish gem that isn't real? A shamrock. So I'll go through a bunch of funny jokes throughout the semester just because that's who I am. And we have a lot of fun. So we do have a field class that we run in spring. So it's every spring. This last spring we went to Death Valley, and this is the group. This is all the Fresno City college students with some Fresno State students. So we go with Fresno State's geology program. They bring some non-geology majors. They bring some geology majors. They bring some teaching assistants in geology, and they bring some faculty. And we just have a lot of fun kind of exploring an area. So this next spring, we're going to go to Coast Ranges of California. And I am the instructor for that course. It's just a 1-unit course. You do a 4-day field trip. You have a lot of fun. You make some friends. If you plan on transferring to state, you get an opportunity to talk to students that are currently going to state in all different majors. And if you like camping, we camp. So if you want to take that course, it's really awesome. You just need the 1-unit course fee. And then we do ask you to pay for your food. And then outside of that, that's all it costs to go on this little mini 4-day vacation. It's usually a Thursday through a Sunday. And you have all of the opportunity to tell all your other teachers, I have to go. It's for another class. So I think it's fun. And my students had very good feedback last year. Some of them will do little talks for us at different locations, which is fun. So yeah, if you're interested, just let me know. All right, so lastly here, we're looking at the scientific method. I'm not going to go into this like super full-blown because I know that you've seen this before. Scientific method is everywhere, right? Especially if you take a science, they hammer you with the scientific method. You want to recognize a question and observe a problem. You want to hypothesize, then experiment and collect your data. Then you're going to analyze and conclude, and then you're going to make a report or present your findings in some fashion, and then maybe you go back to the drawing board and start a different experiment or create a new hypothesis. So you do this in everyday life and you probably don't even realize it. So for example, you go to walk outside and it's pouring rain. Well, in Fresno maybe not, but it's pouring rain, right? So you have this problem, you have this observation you've made, it's raining, and you don't want to get all wet before you get to work or you get to school. And so you hypothesize, well, maybe I can just use my jacket to put over my head because it's probably not going to rain for that long. Okay, so you run an experiment. So that's your hypothesis. My jacket will protect me from getting wet. And then you run an experiment. So your experiment is, I'm going to put the jacket over my head and see if it works. Then you analyze what happened during that experiment. Did you get all wet or were you protected from the rain? And so then you can report out and say, well, maybe I didn't get that wet, but it didn't work very well because my jacket wasn't waterproof. So then maybe you would hypothesize and revise that, well, next time maybe I should get a waterproof jacket and that would work. Or maybe I should just get an umbrella. So that whole sequence of events, you are running through the scientific method without even realizing it. Okay, so we will do that a lot in class and in your labs. So your first lab will be doing a little mini experiment at home with some ice cubes, and you'll see which one melts the fastest based on the scenarios that I give you. Okay. So with that, your weekly assignments are the 2 lectures, and those have quizzes, so make sure you do those. Those are your quizzes for the week. And then you have the lab, which is set up like a quiz, but it goes into your lab points, and you have multiple attempts to complete it, so you can get the highest possible credit on that as you wish. And then you do have a solar system discussion post to work on, okay? So if you have any questions throughout, just let me know, and I will catch you guys in the next one. Bye.